Okay, one of the most important lessons in the class, we are going to represent functions on the Cartesian plane because functions give me a relationship between x and y, or rather two variables, right? You can say y is equal to f of x. So then I can plot points in this plane that satisfy this relationship where the point xy is such that y is the output of the function at the point x. So let's plot this. So my vertical axis, my y-axis, is going to be the outputs of the function at specific x values. So let's take this relationship right here, and let's write it as a function of x that gives me a y value. So I want to write y is equal to f of x. So let's take this 2x plus 4y minus 2 is equal to 2, and I want to write y is equal to f of x. So solving this for y, let's throw that 2 over to the other side. Let's subtract 2x. And let's divide by 4. Okay, so y as a function of x is equal to 1 minus 1/2 x. So now let's plot a few points. So here, the function f at the point 3. If I plug in 3 for these x's, I get 1 minus 1/2 times 3. That gives me minus 1/2. So the x value of 3 gives me an output, gives me a y value of minus 1/2. So 1, 2, 3 gives me a y value of minus 1/2. So that's a point that's on my function. Let's find another point. What does the function do to the x value of 1? So this relationship, if I plug x is equal to 1 here, I get 1 minus 1/2 times 1. That's 1 minus 1/2, or 1/2. So for the x value of 1, I get an output, or a y value, of 1/2. So when x is 1, I get a y value of 1/2. And hopefully it's getting repetitive at this point. Let's keep going. F at 0. 1 minus 1/2 times 0 is 1. So the y value, the output of my function, at 0 is 1. So when x is equal to 0, my y value is 1. All right, let's keep going. F at minus 2, I'll skip the steps here. Should be a 2. So when x is minus 2, we have a y value of 2. And finally, the function at 5/2, or 2.5, gives us a minus 1/4. So 2.5 minus 1/4, something like that. So in fact, you see that we're getting a straight line. And we're getting a straight line because that's exactly what the function was. If you look at your definition of the function, your y values were given to you by 1 minus 1/2 x. That's a straight line with a slope of minus 1/2 and a y-intercept of 1. So the big takeaway here is, for all of these x values, you plug them in to this function here, and the output is your y value.